Because not all angles yield ratios for sine and cosine and all our trig functions that are nice, it can be beneficial to use our calculator to approximate our answers. So let's take a look at an example. Here we have 7 sine of theta equals 1, and we are going to be looking at the interval 0 to 2 pi. So let's isolate sine of theta. That will equal 1/7. This is not a ratio from one of our reference angles that we know. So therefore, let's go ahead and look at what the reference angle would be. So to look at the reference angle, we simply ignore any positive or negative. So here we have 1/7. We don't have to worry about it being negative. I mean, of course it's not anyway. But the reference angle would be arc sine of 1/7. So this is an acute angle in the first quadrant. And if you always choose the positive version of this ratio and use your inverse trig function, then you should end up in the first quadrant with an acute angle, and then you can just go ahead and manipulate that value however you want. So let's look at where sine of theta would be positive. We would have quadrant 1, and we would also have quadrant 2. If we're in quadrant 1, theta is simply arc sine of 1/7, which is approximately, make sure that your calculator is in radian mode and use your inverse sine function, and you'll obtain 0.14. In quadrant 2, however, let's take a look at a picture. We have our axes and our reference angle must be this angle, and so therefore I need to take pi and subtract our angle, our reference angle, and so that will be pi minus arc sine of 1/7, which according to our calculator is about 3.00. And again, we're rounding to 2 decimal places. Now here we have an equation that is of quadratic form, so it may be beneficial to look at this as 4u squared plus 13u plus 3 equals 0, and factor that expression on the left. Now, you would continue to solve if this were in terms of u, but let's go ahead and switch back now to cosine of theta. So our left-hand side of this equation we can factor in a similar manner. This will be 4. Instead of u, we'll write cosine of theta plus 1, and then u is cosine of theta plus 3, and don't forget this equals 0. Now, either one of these could equal 0. So therefore, that means that cosine of theta could equal negative 1/4, or cosine of theta could equal negative 3. So now let's go ahead and look at cosine of theta equals negative 1/4. Cosine of theta equals negative 1/4 would yield a reference angle. And remember, for the reference angle, we ignore the positive or negative version of it. We just look at arc cosine of 1/4. That will be an acute angle in the first quadrant. So where is cosine of theta negative? And this would be in either the second or the third quadrant. So if we look at quadrant 2 or quadrant 3, we should be able to get our representation. So in quadrant 2, here's our reference angle. So our angle would be pi minus our reference angle. So quadrant 2, theta would equal pi minus arc cosine of 1/4, which is approximately 1.82. Now if we look in the third quadrant, there's our reference angle, arc cosine of 1/4, and we will take pi and add our reference angle to it. So in quadrant 3, theta would equal pi plus arc cosine of 1/4, which is approximately 4.46. Now, you'll remember that we need to go back and we had this piece to deal with. Cosine of theta equals -3. But you'll remember that the range of our cosine function is -1 to 1. So therefore, there is no solution to this portion. And these are your answers. 1.82 approximately and 4.46 approximately.